Hey everybody, let's do some review for this quiz. Two parts, non-calculator and calculator. These three questions are the non-calculator questions. Maybe not exactly, but you will have to draw three things. A function from an equation, an even function, and an odd function. Or possibly one that's neither even nor odd, so like on the paper here. Remember, the order matters when doing all this. So let's just do a quick reminder of what the order is. Of course, you go left or right first, and then you want to shrink or stretch. And then after that, you would reflect. And then finally up or down. Now we know for sure that when you have shrink or stretch, the order matters, but also a lot of times if you have reflect, the order matters. And this is going to be one of those things. So we know we're reflecting over the x-axis, and you don't have to make a list. I just am for some reason. We're going to go right 3, and then up 4. Right 3 affects the x, up 4 affects the y, and a reflection around the x also affects the y. So because we have two things impacting the y, you have to do the order of operations correctly, which multiply occurs before adding in PEMDAS. You think, what does that have to do with anything? You don't have to know that if you know the order. If you don't know the order, then you got to know PEMDAS. So multiply happens before adding, and of course reflecting around the y means we're going to multiply the x by -1. So you can do this on the picture. I'm going to do this with the numbers. Because the order matters, the picture would be kind of easy to be confused with. We know that the parent function is 0, 0. And if you don't, just think, well, what is the square root? Right? So I can take the square root of 0. I can also take the square root of 1. I cannot take the square root of 2 or 3, so I'm not going to use those numbers, but I can take the square root of 4 and get a 2. So you can always calculate those numbers if I can't remember them. So left and right is first, so that means we're going to add 3 to all of the x's. And then after that, we want to reflect. Reflect means multiply the y or change the signs on the y. Multiply the y by -1. And just because I have a lot going on here, I'm going to rewrite this just so I can keep track of myself. So this is going to be 3, 0, 4, -1, and 7, -2. And now finally we finish this up with the up 4. So the vertex, or the original point, I guess not a vertex, is at 3, 4. Now from here we have no vertical stretch, and we know we reflected it. So if you want to count with the patterns, we know it goes down 1 over 1. Or if you want to use the points that if you've calculated them, you know this is at 4, 3, and if you look, it's the same thing. And then for the last point, because it looks like a line right now, from the starting point you would go down 2 over 4, or you can use the points that you have, which is of course 7. 2, if I can read my handwriting. This is a 2. So 7, 2. This actually goes to 8, so 7, 2 is right there. And there's the graph. So you will have to do that. And you know, the order is probably going to matter. To draw a function that is even, there's no reason to go crazy. You know some things that are even. Absolute value is even. I'm just going to stick with something simple. You know, parabolas are even. Just make sure the y-axis goes right through your function. There's no reason to be super extra. You could draw it upside down if you want. A function that's neither even nor odd. I'm going to stick with absolute value again, and I'm just going to, I don't know, move it over here. Just move it away from where the y-axis runs right through the middle. It doesn't matter. You could draw it over here. You could, you can put it really anywhere. Or you could use a parabola. But I would suggest to you that you don't go crazy on that, because sometimes that makes it wrong. The rest is on the calculator, so keep that in mind. So you can use your calculator for any of this. If you're bad at piecewise graphs, use the calculator. Now you can't put the entire piecewise graph into the calculator, but you can do it piece by piece. So you could just type in that top piece and then look at the table of values, and you're only interested in 0 and numbers smaller than 0. So go to the table, type this in, type in y equals the absolute value of 2x plus 2. Absolute value is math, math key, third one down on the left, and then you're going to arrow over on the top to NUM, and absolute value is right there, ABS. So that's, if you don't know how to graph it, that's the best way. Use the calculator. So when you look at the table, you'll see that these are the y values. So we're going to have 0, 2. Now we know this is closed because this thing has a line under it. And then we come down here to -1, 0, and then -2, 2. Now the second piece is a line. You don't want to graph this line? Put it in the calculator. I'm going to graph the line because if you plug in a 0, you end up with 0 plus 1. We get 0, 1, and that's open. So I know this is open. That's my starting point. The slope is 2/3, so from there I'm going to count up 2 to the right 3. And that's as easy as that is. Or you, like I said, use the calculator. Put this in the calculator. Draw that graph. There's no reason to picture it if you don't want to. You'll see that the y-axis runs right through the middle of it. Now for this one, you have some simplifying to do. We have a graph. So g of x, and it is a vertical compression of x to the third plus 1. So the vertical compression, vertical would be on the outside, so you'll have to add parentheses. Now, in order to move that up 5, we have to do some simplifying. You are going to have to distribute this. So we get 1/3 x to the third plus 1/3 plus 5. You don't like to add fractions? Put it in the calculator. Remember, you don't really have a fraction key, so you just do 1/3 plus 5, then math, enter, enter, and it'll switch it back to a fraction for you. So this is really going to be, if we make this a common denominator, multiply that by 3. So this is 15/3. So 15/3 plus 1, g of x is officially 1/3 x cubed plus 16/3. Now, if it did not dawn on you to sort of distribute that, and you left it like this, you would get partial credit for that. Just so you know, in case you think, there's no way I'm going to remember to do that. You'll still get some. There will be some multiple choice. I don't know how many or which ones they are, but just to give you an example of what that might look like. Which of the following would transform this to an odd function? So I don't know how this could ever be odd. I think it's not supposed to say odd. I think it's supposed to say even. Sorry about that. So let's draw this graph. Or look at it in your calculator. You don't have to draw it. But it is basically over here. And in order to make this even, because you can't make this odd, so I apologize for that typo. I didn't realize that. All we'd have to do is slide it so that it looks like the y-axis would be right through the middle of it. We don't need to move it up or down. All you need to go is slide it to the right. And so since it's 3 to the left, which you can tell, right, because it's that, so then we'd have to just slide it 3 to the right. To find the real zeros, put it in the calculator. Look for where it crosses the x-axis. Or put it in the calculator and look at the table. And look for what does it say when x equals 0? What does it actually say in the table for x equals 0? Because sometimes a graph is kind of hard to tell. And if you look at the table, it tells you 0, 0. Because it only crosses the x-axis once, so that's why you can do it that way. Describe the end behavior. Again, draw the graph if you want to draw the graph, or if you know what negative and odd does. Negative and odd would look like this. So we know that as x goes to infinity, so x goes to the right, y is going down, so negative infinity. And as x goes to negative infinity, or to the left, y is going up to infinity. Intervals of increasing or decreasing, put it in the calculator, look at the graph. This is always decreasing. The calculator portion really is designed for you to use the calculator. So I'm just pointing that out. Keep that in mind. Use the calculator. There's no reason to guess at these graphs. The graph will give you a lot of the answers, the actual picture. Then we're going to get into some composition and inverses. Composition, as you know, take one function, insert it into the next. I'm not saying you'll have this many problems on the quiz. I just wanted to give you some practice of all the different things. Of course, we have to state the domain restrictions if we have any. So we're going to start with function f, which says, hey, we got the square root of something plus 2, so the something is the g. goes in there. And because everything's underneath the radical, we can combine like terms. That's the answer for the composition. Now we need the domain restriction. Because we have that square root, we know whatever's underneath there has to be positive or greater than or equal to 0. So we get x is greater than or equal to 3/4. That is your domain restriction. Answer, domain restriction. Going the other way, starting with G. G says to take 4 times something minus 5, and we're going to insert this radical. If you have parentheses, that's no problem. It just doesn't have any meaning. This is the answer. Then we need to find the domain restriction underneath the radical, greater than or equal to 0. So we get x is greater than or equal to -2. Finding the inverse of something means switch the x and y and solve again for y. Now, these fractional problems, these rational expressions, these are always tricky. They're not supposed to be, but they end up being tricky. So let's go through this carefully. So we're going to switch the x and y. As you know, this is really y. So now we have x equals 1 over y minus 2. The best friend on these is the cross multiply. It doesn't matter what order you start in. I'm going to go this way first just because it looks easy. And then the other way is x times y minus 2. Since what you're solving for is inside the parentheses, you are going to have to distribute. Oh, that's not an equal sign. That's a minus. So then, of course, add the 2x. And now we're trying to get y by itself, so divide by that letter x. And you're more than welcome to leave it like this. You do not need to make it 2 different pieces. You can just leave it one giant fraction. But it is the inverse. Now this one is always tricky. It's supposed to be simple, but it makes it seem, it reads really crazy. You don't need to find the inverse to actually answer the inverse. Remember what inverse means. Switch the x and y. So if f of x is the same thing as y, right? Here's your x, here's your y. We'll switch them. So this is basically saying that's your y. Because normally inside the parentheses or of the name of f of x is an x, but this is the inverse, so this is really the y. So you know what to do with it now, hopefully, right? It's going to go right there. So we're going to have 12 equals 3x minus 2. Inverse means you're just solving it the other way. That's all you're doing. So 14 equals 3x, and we get 14/3. This last little part, since we spent so much time on it, you know this is going to be on there. So you're asked to find the inverse, and then you're asked to verify it graphically and algebraically. Just so you know, algebraically will be the extra credit problem. So if you're bad at that, or if you're worried about, I can never make that work, it will be just the extra credit problem. Little insider information there. So we're going to find the inverse, which means you're going to switch the x and the y, because that's normally a y. So now we're going to have the cube root of y plus 1. Get the 1 over here. And then take everything to the 3rd power. So we have x minus 1 equals, really, the new name is the inverse, the proper name. Stop calling everything y equals. We don't know what that means. So now we have to verify that these are inverses graphically. You don't have to write anything except you just have to draw their graphs. What we're looking for is that it looks like it is a reflection over that line y equals x. So one graph looks like if you were to fold it on that diagonal. So if we were to fold our graphs on this diagonal, they should look like they would match up. It doesn't have to be perfect. Obviously, the gist is the gist. So use your calculator. So the function of the original, f of x, we know the cube root, sort of. We're better at the other one, but this one is like a sideways, long, skinny. That is the original function. So the inverse, again, put this in the calculator. Oops, sorry, I forgot my power of 3 there. Put that in the calculator and look for some points that are easy to graph. Just enough to give you the gist of it, and then you can draw it. So it does start over here at right? That should make sense. If this is up 1, if this is the point 0, 1, then we should have the point 1, 0 on the inverse. Switch the x and y. It should work out. And then we'll have the point 2, 1. My red line is really not in a good spot, and it's not accurate, but just to give you kind of an idea. This is the inverse. And my red line, I don't know if I can erase it anymore, but my red line is really not exact. So if we fix this guy a little bit, just to show you kind of oh, I erased all this stuff. Better fix this. This was here, here, and here. So the red line would really be 1, 1, 2, 2, really goes through there. So you can see that they are a reflection around that line. Now to show this is algebraic. Algebraic method is to do the composition. So you're going to start with the function and put the inverse in it. And then you're going to start with the inverse and put the function in it. Doesn't matter which one you do first, that's just the way I'm going to do it. So if I start with the original function, remember the original function is up here. So we're going to have the cube root of something plus 1. And then you insert this x minus 1 cubed. Well, the power of 3 and the third root cancel, so we're left with x minus 1 plus 1, and the answer is x. You want the answer to be a plain x. No numbers, no fractions, just an x. If we start with the inverse says, hey, take something, we're going to subtract 1, and then the something is, of course, the entire function, the cube root of x plus 1. Plus 1 minus 1 add up to 0, and the cube root of x to the third, power and root are gone, and we do get x again. Let me know if you have any questions, and that's going to be the whole quiz.